Hi, good morning, everyone. My name is Mark Littlefield. I'm a vertical product manager for defense at Kontron. For those of you who know me, and probably know half or so of the crowd, you know that I'm probably, I'm a very strong advocate and speak very openly about my advocacy for SOSA. And so I'm not going to disappoint you. I'm going to talk about SOSA. But hopefully I'm talking about something that is maybe not quite so obvious to everyone, and so you guys might find it interesting. It's a little light. We've had a lot of great speakers this week so far. This one's going to be a little bit more light, so it's a little like, you know, the sherbet in between the courses in the meal. So I'm going to start by stealing a slide that I saw yesterday that I loved. Shen from Elma showed this slide, but it's really that chart in the lower right-hand corner there. The fact that when complexity increases, the cost increases so dramatically. And in a lot of our systems in VPX today, that's where we are. And so SOSA is all about driving that down. That's the whole reason we're doing SOSA. And what I'm going to do is I'm going to show why that's not only going to affect sensor systems, but it's going to affect the entire VPX market. And in fact, any integrator can make use of what we're doing in SOSA to a greater or lesser extent to achieve this. So, you know, in case you were asleep yesterday or you've been living under a rock for 2 years, SOSA is a government industry consortium. And I'm just going to read it here because it says it best. A government industry consortium created to collaboratively develop open standards and best practices to enable, enhance, and accelerate deployment of affordable, capable, and interoperable sensor systems. So that's a lot, but it's really designed to drive down the costs and the efforts needed to integrate VPX systems, complex VPX systems, and then to enable and make it easy to do technology insertions later down the road. Super important. Warfighters facing ever-evolving threats, and the threats are evolving faster than ever. We need to be able to upgrade our systems faster than ever and easier than ever and cheaper than ever in order to be able to keep up with those threats. That's what SOSA is doing. Now, there's been a lot of open systems efforts in the past. A lot of people, in fact, I get asked to go to visit customers and tell them why we think that SOSA is important. And invariably, it's always, this is yet another open systems effort. Why is this different? Well, this is different because all three agencies or services are backing this. It has wide industry embracement. Is that a word? Anyway, there's big participation, much larger than any of the previous efforts. And so for that reason, and because everyone is going in not trying to protect their previous interests. Everybody is going in really wanting to solve this problem, and we're getting there. We're solving this problem. So just briefly, a couple of the key elements that we're focused on in SOSA: architecture, hardware, software, electromechanical, and then the business aspects of how to use the open standard to be able to define in the RFP stage and then in the bidding stage and then in the deployment. And then there's naturally subgroups that are attacking individual problems within that space. So although SOSA, for those people, those organizations, and those products that are driven by the government to participate, conformance to the standard is going to require certification. But what I'm thinking and what I'm projecting is that a lot of non-SOSA platforms will be able to benefit from it. And I'm going to talk about why I think that here. So can they benefit? Absolutely. I'm convinced of that. So a lot of people, one of the first questions I get asked is, why SOSA? You know, we already have Vita. Isn't that a set of open standards? Well, yeah, it is. And what's the difference? Okay, well, The difference is there's not a whole lot of difference. We're drawing from the Vita standards into SOSA, and likewise, whenever we innovate in SOSA, we try to drive back into Vita where it's appropriate. So one of the key things to understand is that we're adopting these standards, but we're limiting their scope, saying we're taking this standard, but you're only allowed to use these portions. And we have good reason for it. And we've got use cases that we test against to make sure that the decisions that we're making are sensible, sound decisions for building these kinds of systems. So a couple of key things. Only a limited number of slot and module profiles will be supported. Very strongly constraining that. Only certain options that are given within OpenVPX are permitted. Again, to more better constrain these systems. Whenever we create something new, we try to drive it back in. A couple of examples. Jerry talked yesterday about Vita 62. What we're doing there, we're driving back into there. There's new system management content that's being discussed that will eventually be driving back into 46.11. And that's not to mention the things that we've already done in OpenVPX that we've driven back into there. And then lastly, SOSA kind of goes beyond hardware and addresses software and system architecture details and things like that, beyond what's typically covered within a Vita standard. So it's really kind of an ecosystem. So how is SOSA going to impact the market beyond just those sensor platforms? So number one, multiple vendors with common slot profiles. I've got a slide coming up, so I'm not going to go into all the details in all of these. Better definition of certain common VPX elements, things like NVMRO and how serial ports are used as console ports. More ubiquitous and complete system management. 46.11 has been out there now, close on to 10 years, but it's still kind of a minority of systems are using it. I think we're going to see an acceleration of that because we're driving implementations and more complete implementations and new extensions within SOSA. The tighter definition of the power usage, Jerry did a good job of that. I'm not going to belabor that. The emergence of SOSA compatible XMCs. As an integrator of having to help customers figure out how to fit XMCs solutions into our baseboards, I don't know how many times I've been frustrated by incomplete mappings where we have a great XMC that we can't map everything to the backplane because the board doesn't support the exact mapping. No more of that. And then the emergence of SOSA-compatible software frameworks and tools really opens up the possibility that there's going to be off-the-shelf solutions that can be just used and quickly integrated into your platform. So as a result, non-SOSA integrators can benefit from SOSA directly by taking the standard. It's an open standard. It's going to be published. Everybody can use it. And taking the parts of the standard that affect them and they want to make use of, or just even indirectly by using the SOSA-aligned products. Why not? You know, you don't have to go out and get certified, but you can benefit from all the work that we're doing. So let's take a look at OpenVPX versus SOSA. And just picking one thing, taking a look at the slot profiles. The column on the left is the count of slot profiles within the standard. I might not have it 100%. I counted it by hand, so maybe I didn't get it quite right, but it's close enough that it gives you a sense. On the left is the number of slot profiles that are in OpenVPX for 3U and 6U by the different categories of boards. On the right is SOSA, okay? In addition, every slot profile's got module profiles, multiple module profiles. And again, we've constrained that within SOSA. So it's just a limited set of what we're supporting. And then lastly, and if this doesn't drive it home, nothing will, is that virtually all OpenVPX profiles have user-defined pins. So even though you have something like a 2F2U, which is probably the most common 3U VPX profile in OpenVPX, look at all that white. All that white means that every vendor is allowed to implement whatever they want on those pins. Instant incompatibilities. And certainly, when you take a board out and want to do a technology insertion, virtually impossible. So in SOSA, we've adopted two base profiles. The one on the top is called the I/O intensive profile. The one on the bottom is called the payload or compute intensive profile. And in effect, anything that does computing or I/O that's non-switching, and we have one exception that's kind of special for like hooking up to aircraft discretes and things like that, has to be one of these two profiles, okay? And we're already, well, for anybody who's going to go over tomorrow and see, you'll see the results of this. So I mentioned the minimal variability in the XMC mappings. 3U and 6U have their own mappings, but they're very similar, and we're going to see alignment within the XMC community to these profiles, and just makes XMC integration and use much, much easier. The 12-volt centric power, I've been advocating for that for a long time, so I was really glad to see that. Basically, anybody who was designing systems previously had to do up their power balance, figure out how much 5-volt, 12-volt, and then go to their power vendor and say, what do you have? And they'll say, nothing, it's a custom power supply. Well, that's going away now. Now it's going to be, do you need one power supply or two or three? The maintenance ports. Sounds like it's a trivial thing, a console port on a board. Well, every board's got a console port. Problem is, they were all over the map where they showed up in the profile, okay? No way of getting any consistency. So we have put them in a specific place and said, this is where the console port is on a board, okay? In addition, we've defined RS-232 voltage levels and LV-CMOS levels. LV-CMOS, right? LV-CMOS. So why did we do that? We wanted to be able to aggregate those signals into an FPGA, so you could basically form a little switch and be able to like telnet into there and be able to hit any of the boards within a system with a single Ethernet port to that FPGA. Makes it super, super easy to aggregate. Yeah, it says LV-CMOS. I should have looked at my chart. So some of the other things that are maybe, everybody looks at OpenVPX and say, okay, yeah, I know what aux clock is, I know what a ref clock is, I know what an NVMRO signal is. In fact, there are many, many interpretations of what's in OpenVPX that are basically incompatible. And so we're defining those and saying, this is what it means to use these signals. These are the rules that you can connect them. This is how they can be used. NVMRO, for instance, when can it be asserted? I'll tell you, it's all over the map. People say, oh, I need to be able to assert it and deassert it at will. Oh, no, it can only ever be asserted by a jumper on the front panel. It can be anywhere. So we've put strong rules in to define how those things are used. And then lastly here, I'll mention fewer pitch options. Tell you the truth, I always thought it was crazy that we had, 4 pitch options within VPX? Why do we need that? That's crazy. So certified solutions for things like software, security services, system management, just makes it easier to integrate these systems. We'll have packages that will provide in a predictable and pre-certified way things like authentication, authorization, logging for security purposes. And from system management, we'll be going well beyond what's offered today in 46.11. We'll offer things like health logging, bit management, more integrated management between both the platform and the application. So, and there's good things and bad things about that, and those things are still being argued within the subcommittees in SOSA. But being able to go beyond just the simple looking at the hardware through IPMI commands and turning a slot on or off, it's going to give you a lot more control, a lot more visibility, and a lot more ability to do things like prognostics in a standard way with off-the-shelf tools. And then lastly, we're seeing where we're adopting frameworks and middlewares so that from a software standpoint, it's easier to do integration. The FACE OSS and TSS are examples. There's specialized things like Mora that's been adopted. The Victory is being adopted. but also more common things like DSS recently was adopted. I didn't even get it into the slides. It was recently adopted. It's going to show up in the next snapshot. And there's going to be more. Just again, makes it easier to integrate these systems and to use these off-the-shelf tools rather than inventing your own, or just picking one from some vendor and then not knowing if that vendor or that solution will be around in 10 years. So, in conclusion, SOSA is not something that's happening in the future. It's happening today. From our standpoint, we've been shipping aligned products since December of 2018, and we've been in production with 2 SOSA aligned SBCs, one IO intensive, one compute intensive, since summertime. And all of these guys have either announced or are already shipping SOSA aligned product. I think virtually all of these guys will be showing over in the other event. Come talk to us. We're already cutting our teeth on how to integrate, and we're bumping into things, then we're addressing those things when we bump into them. It's an exciting time. And for me personally, I was co-chair of OpenVPX in the early days, and I left unsatisfied with what we came up with. And I think that we're solving a 10-year-old wrong by this effort. If anybody wants me to come in and talk to an event, talk to the media's here, I think I've talked to just about everyone about and mentioned SOSA. I can't stop talking about it. I'm that excited about it. So with that, thank you very much. Thank you for coming and letting me cheerlead a little bit.